Hi everyone, welcome to this video in which I'm going to show you how to install and the basic use of one of my favorite mathematical programs, which is WinPython. Okay, so in order to do this, let's first install to see how to install the program. For this, we can go to our browser and do a search in which we can write WinPython. Okay, and then we will see this link here. We press here, and then we have here the main website to download this program WinPython. Okay, with the different releases. Okay, the last version is, I think, is 3.9. I have installed in my computer. I think that I have installed the 377. Okay, so it will be like this. I recommend at least to install a version in which you will have the spider. Okay, this one or this one. Okay, or if you like, you can install a newer version. Okay, so for example, if you select WinPython 3.8, then you press here, search for, and then you can select here the version that you want to download. Okay, for example, this one here should be okay. Okay. So a little bit more of information about WinPython. We have here an overview. WinPython is a free open source portable distribution of the Python programming language for Windows. Okay, and it is intended for scientific and educational usage. Okay. The good thing of this version, WinPython, is that we have many modules for scientific applications already coming with the program, okay, like NumPy, SciPy, SumPy, Matplotlib, and so on, okay, and others. We are going to see some of them later. It is portable, it is flexible, customizable, and so on, okay. Usually when we start the program, we can do an standalone installation in which we are going just to decompress all the files and put them into a folder. Okay, but if we like, we can do the registration in Windows, so it is going to appear also in the Windows menu. Okay, but it is not necessary. Let's see now what we get when we install our program in our computer. Okay, for this we can go to our disk, then enter in the installation folder, which is this one, WinPython 64b377 in my case. Okay, so I enter here, and then we have here all the files corresponding to our program. Okay, this is the main program. We can start Spider here, pressing here. We can get also a shortcut in our desktop. Okay, but we can start the program here also. And then some interesting things that we can see here, for example, is that we can see the different modules that we have installed in our program. Okay, and this can be done here with WinPython control panel. Okay, we press here, and then we can see here what package we want to install and what package we want to remove, and so on. Okay, so if we come here, then we can see the different packages that we have installed right now in our computer. Okay, so we can see a little bit of information about about the function of the package. Okay, for example, a common package can be this one that we are going to use later, matplot library. Okay, this is a library for doing two-dimensional plottings. Okay, so now if we want to install a new package, we can do it several ways, and we can go here to the folder of the program and then execute this program here, WinPython command prompt, and then here we can do like this, pip install and the name of the package that we want to install, say for example matplot library. Okay, and press enter. Okay, going to increase the size of the font to see it better. Okay, pip install and then the name of the package. If I press here now, then the response is that this requirement is already satisfied. Okay, so we have already, as we have seen, installed the matplot library and ready to use in our system. Okay, so now in order to start the program, we go here and press spider. Okay, and this is going to start our program. Okay, let's start a new document. So we can see that the window is divided in three main parts. This part here on the left is where we can write our scripts for the program. Okay, this part here at on the right at the bottom, this corresponds to the console. Okay, so we can see also here the results of our program. Even we can enter here commands like this, a equal to 3, as we have seen, and say what is the value of a, 3, then b equal to 5, okay, then c equal to a times b, okay, and see the value of c, and so on. Okay, we can even install new modules from here, pip install matplot library. Okay, and then we get the same response that this requirement is already satisfied. Okay, and the other part of the window corresponds to this part here on the left and at the top. So here this is a window for different purposes. Okay, for example, we can see the different variables that we have in our program that we are using. We have another tab here for the help, so we can get help, for example, with the tutorial. Okay, here we will see the plots, the figures that we are going to generate, and then on this tab we have access to the files in our computer. Okay, so we don't have to go to outside the program to access the different files or folders and so on. So we can press here and see, okay, the different folders, program files, and so on. Okay, so we can work here with the different documents very quickly. Okay. The best way to use the program is to write on this part on the left side of the screen our script. Okay, so let's see some example. We can see that we can make one-line comments using the hash symbol or several line comments using the triple quotation mark. okay? With 3 quotation marks, we can do comments like this with several lines, okay? And then we can start here assigning our variables and so on. For example, we can say input variables here and say x equal to 3, y equal to 4, and then say output variables set equal to x times y, okay? And then printing results, okay? And then say print result equal, and then here set, okay? So now we have ready our program. We only have to press here to run our program, okay? So we can save it, of course, if we like. For example, here, okay? And then run our program, so we can see the results of our program in this screen here, okay? Result equal to 12, and we have all the variables ABC that we have defined before, and then S, Y, and Z that are our new variables here, okay? But say, for example, that we can obtain something like a new variable like d equal to sine of x, okay? Then we are going to have a problem here. We are going to see what happens, okay? And say, for example, that we want to print here result 1 equal to d, okay? If we run the program now, we are going to see this error, name sine is not defined, okay? This is because any function that we want to use in our program has to be imported firstly, okay? Has to be imported before being used in our program, okay? So we need to do something like this from math, which is the mathematical library, import sine, okay? And then with this, it should be correct, okay? So we can see our results, okay? So before using complex functions, we need usually to import them before from the library. We could import another function, for example, exponential function, and do something like this, f equal to exp of x, okay? And then copy here and print f in result 2, okay? So it will be something like this, okay? Also, we have to know that for the power function, we use double asterisks, okay? For example, we can say g equal to x to the square, okay? Will be something like this, okay? We can add another one, and this will be g, okay? So now let's see an example on how to represent functions and generating plottings using Python, okay, using WinPython. So for this, I have this example here, okay? You can see that we need to import several functions from different modules, okay? Let's see first how to do the representation, okay? For example, we want to represent the sinusoidal function, okay? Then we firstly define the range and the step for our representation. Okay, so we want to represent our function, sinusoidal function, from 0, x min, to 4 pi. Okay, so we need to define pi. Okay, pi is a constant that is included in the math function. Okay, so we see here that we are doing from math import several functions and also pi. Okay, so we can use pi here, and then the step for our representation is going to be 0.01. The number of points, we need to calculate the number of points which is obtained with this expression. Okay, x max minus x min divided by the step, but this will generate a real number, so we are converting it into the nearest integer. Okay, so we can get the number of points that we are going to use. Okay, then we create here the arrays. Okay, the arrays for our variables, and for this we use the np function, which is inside the numpy module. Okay, so x will be npy. We use the function arrange from numpy with this definition. Okay, x min to x max with this step, and then with this definition for the type of data that we are going to store in our array. Okay, same thing for y. Okay, which is going to be the output, okay, of our function. Then we can calculate values. We do like this for e in range 0 to n points, and then we obtain the value of the function that we want to represent point by point. Okay, so this is our output function y. This corresponds to our array. Okay, in each iteration equal to sign of x of I. Okay, for each iteration. Okay, and then if we like, we can print here the result to check that everything is okay. Okay, so you have seen that from math we have imported this function ceil, sin, and pi. Okay, pi, which is the pi constant. From numpy we have imported this one. Okay, and then in order to plot the function we need to use this module. Okay, matplot library dot pyplot, and we are importing it with the name plt. Okay, and then to plot the function is as simple as doing like this: plt.figure number 1. So with this we create a new figure, and then we represent here what we want to, we write here what we want to represent. Okay, plot x, okay, and y. So we represent here, we introduce here the arrays that we want to represent. First the horizontal axis, and then the vertical axis, and then we can include the color in which we want to do the plotting. Okay, then with this we can say if we want to show the grid in our plotting or not. With this we give a name for the label of the x-axis. Okay, in this case, for example, time, and using the dollar symbol we can include scientific notation. So this will be represented like t sub x. Okay, same thing for label in the vertical axis. Okay, so we don't need this R here right now. We can talk about this later. Okay, so with this, in principle, we have everything ready. Okay, so we can press here, and then the results are going to be seen here in this console. Okay, so because we have selected to print all the values, we can see here all the values corresponding to the y and x. Okay, we have included here to print x and y arrays. Okay, so for each value we can get the value of the function. And if we want to see the plotting, the graph, then we go here, plots, and we can see here our plotting. Okay. From here we can even save with right click on the mouse. We can save the plot. Okay, and save the plot in our disk. And now to finish this presentation, we can see other things that we can do with our graphs. Okay, for example, we can add a title for our plotting. Okay, so if we remove this comment here and then execute the program again, we can see how we have here our title, my function, okay, in our graph. Okay, we can also control the limits for both axes. For example, here we can use this command here, plt.ylim. Okay, so with this we are going to limit the vertical axis between -1.5 and 1.5. Okay, so if we press here, we can see now that the vertical axis is formatted this new with these new limits. Okay, same thing with the x-axis. Okay, for example, between 0 and 3 pi. Okay, then run, and then we can see that this is our new range for the x-axis. Okay. Also, we can use Greek letters in our representation. For example, if in order to do this, in my title, for example, if we want to include Greek letters, then we add the letter R here at the beginning, and then inside we use the dollar symbol for the scientific or mathematical notation, and then we include backslash, and then alpha, for example, and dollar. Okay, same my function alpha, and then if we execute, then we can see that we can use also the Greek letters in our representations. We can include also text in our function in any part of the graph. For example, if we include here this plt.text, then we locate this text in the position that we want. Okay, in this case 308. Okay, my sign function is the text that I want to include, the size that I want to use, the color for the text, and the background. You can also use background if we want. Okay, so if we press here, okay, then we can see the text here in this position. Okay, is 3 and 08, x and y coordinates for the position of the text. And finally, if we want to save our graph, then we can use this command here, plt save figure, the name of the figure, and then the resolution DPI 300 in this case, and then if we press, okay, and go to the folder in which we are working, then we can see that we have here our graph. Okay, our figure, we can open it and see it, even we can modify it if necessary. Okay, so this is all for this video today. I hope you have found it interesting and useful for your future activities. Thank you very much for watching this video and see you in the next one. Goodbye.